Hi folks, this is level 2, dimensional analysis level 2, and we'll start with number 1 here. Density of balsa wood, 18.9 pounds per cubic foot. What is a mass in grams? So I want grams. The information that is not given here, but which would be given on the exam, is the fact that there are 454 grams in 1 pound. Now, there are more significant figures possible for this, but I'm going to give you this. And because this is the given information, you must consider this a definition. When you have such a definition, you should ignore the significant figures. Uh, when I give you such a definition, I always have to give you at least as many significant figures in the definition as you have in the problem. So here you have three, actually you have two significant figures, so my definition has three significant figures. Later on, when you find such definitions for yourself, you will have to do the same thing. Your definition will have to be to at least the number of significant figures as the data, if that's applicable. For some definitions, um, there aren't many significant figures. For example, 1,000 meters in 1 kilometer. You can't consider any significant figures there, even though it looks like there's only one significant figure, because it's a definition. So, sorry. Grams. So I want grams. So there are pounds here, so I'm going to start with these grams. 454 grams is 1 pound. It looks like I've got 18 pounds. 18 pounds. Oh, sorry, 18.9 pounds. 18.9 pounds in 1 cubic foot, which is feet cubed. That's too messy. 18.9 pounds. There we go. In 1 cubic foot, so pounds cancel. I need to cancel cubic feet. So it looks like I'm going to find a volume in inches, and there is a rectangular piece of balsa wood with these dimensions. So I'm going to have to say that in 1 foot there are 12 inches, but this whole thing needs to be cubed because we're talking about cubic feet. And now here are the inches, 2 times 4 times 10. So 2.0 times 4.0 times 10. See, that's inches times inches times inches. Inches times inches times inches is inches cubed. Notice the cube does not go out here because these are already inches. Inches, inches, inches. That's already inches cubed. You do not need to cube this. Okay. Only thing left is grams. So I've got 454 times 18.9 times 2, 4, 10. What is it? Oh, yeah. 454 times 18.9 times 2, 4, 10, and that was divided by 12 cubed. 12 cubed. Divided by anything else? Nope. The ones don't matter. Okay, that's 397. So it's 3 significant figures, but I only have 2 significant figures right here. So it should be 400 grams. Now, it looks like 1 significant figure, but to make it clear that you're saying 2 significant figures, you should use scientific notation. 2 significant figures. Okay? Sip of wine, blah, blah, blah. So we're looking for the cost. That means we're looking for money. So I'll start with the money. 278, 24.5 fluid ounces. Fluid ounces. All right, now I have to get rid of fluid ounces. 1 fluid ounce is 29.6 milliliters, so 1 fluid ounce is 29.6 milliliters. So now a sip of wine is 2 milliliters. 2 milliliters is 1 sip. You don't really have to put sip, but you'll see in a moment that why that is. 278 times 2 divided by 24.5 divided by 29.6. Already forgot. 278 times 2 divided by 24.5 divided by 29.6. We have 0.767. 0.767, but there are only 2 significant figures right there in that measurement, right there. There are only 2 significant figures there, so 0.77. 0.77 what are the units? Milliliters cancel out, ounces cancel out, so it's dollars per sip. Dollars per sip. So you could just say 0.77. You don't need to have the sip there because sip is not a real unit. But just to help you to understand the work, I include it right there. Okay. Now, you could say that 2.0 milliliters is a definition. However, notice that there is a zero there. If this were a definition, the zero would not be necessary. So that's why I include this 2.0 in the counting of the significant figures. Moreover, this is money, so it's usually most convenient to just take money to the hundredths place, although the gas station doesn't do that. Most other places of common everyday life just keep money to the hundredths place, so I don't mind if you do too. Let's see, well, in this problem. Determine the thickness of a piece of aluminum foil that has this mass. It's centigrams. This is the density. So the thickness is in millimeters. So there are 1,000 millimeters in 1 meter, and in 1 meter there are 100 centimeters. I'm converting to centimeters because centimeters are in the problem. And now, let's see. I need the thickness. Oh, okay. So I'm going to, let's see, what am I going to do here? Actually, I am going to convert, okay, there are several ways to do this. You encountered this problem in your lab, but because I started this way, I'm going to continue this way. So I'm going to convert this number into cubic millimeters, and then I'm going to solve for the millimeters. So let me show you what I mean by that. 1 centimeter cubed is 2.70 grams, right? And then the mass is 1 gram has 100 centigrams, and there are 0.1147 centigrams. Centigrams I have arranged so that they would cancel. Grams I have arranged so that they will cancel. But centimeters cubed cannot cancel with just centimeters. The whole thing has to be cubed, and then I can cancel those. But meters cubed cannot cancel with just meters. This whole thing needs to be cubed, and then I can cancel those. So with this method, I'm going to do 1,000 cubed divided by 100 cubed divided by 2.7 divided by 100. So that's 1,000 cubed divided by 100 cubed divided by 2.7 divided by 100. So that's 3.7, 2.70. Oh, now this is times 0.1147, I forgot. Times 0.1147. So that's 0.425. Looks like there are only two significant figures. Oh, wait a minute. In the problem that I just did, in the calculation I just did, there are three significant figures. So this is 0.425. So this is 0.425, and that's cubic millimeters. These are the only units that are not crossed out. That is the volume of the piece of aluminum foil, but they're not asking for the volume, they're asking for the thickness. So you know that the volume equals length times width times height from your lab, and that equals 7.0 centimeters times 3.6 centimeters, and this is going to be times x, okay? Because the volume equals 0.425. So I can say right here, 0.425 millimeters cubed equals all this. But see, this is millimeters cubed and these are centimeters. So I need to convert all these guys to millimeters if I want to do the problem in this way. You don't need to do the problem this way, but if you want to do the problem this way, you have to convert everything to millimeters. There are several other ways to do the problem. So this equals, now there are 10 millimeters in a centimeter. You can do that by, you can get that answer by converting yourself in some margin of the page. So 7 centimeters, where 100 centimeters is 1 meter, and 1 meter is 1,000 millimeters, you will end up with 7.0 centimeters equals 70 millimeters, 70 with two significant figures, so 70 dot. So I just happen to know that there's a factor of 10 difference between centimeters and millimeters, so I'm going to directly stick in here the millimeters, and then this is times the variable x. Okay, I'll divide both sides by 70 times 36 to get x, so x will be equal to 0.425 millimeters cubed divided by 70 millimeters divided by 36 millimeters. So that's divided by 70, 70 divided by 36. So that's going to be, is that right? That's going to be 1.7 times 10 to the minus 4. Now, there are only two significant figures right here and right here. So x is equal to, equals x. 1.7, this is not a, this is just a scribble out. 1.7 times 10 to the minus 4 millimeters. Now that's very thin. That's extremely thin. And I think you've encountered such thinnesses in your lab also. So 1.7 times 10 to the minus 4, that's the thickness in millimeters of that foil in this problem. Now that seems a little too thin to me because that is not even a micron. That's not even a micrometer. But I saw some of your calculations in the lab last time, the density lab. You also had very ridiculously thin numbers for the thicknesses of the foil. So either the foil really is a micrometer or less in thickness, or there is something wrong with the density number. The density of the aluminum given here must not be the density of the aluminum in aluminum foil. Why would that be? That would only be the case if aluminum foil were not pure aluminum. If it were some alloy mixed, aluminum mixed with maybe tin or something. Actually, I think tin might be denser than aluminum. Oh yes, so that would change the density here. So that would, what would that do? That would make this number larger, which would make this number smaller, which would make, it would make this number smaller. And if this number is smaller, then you would still have a smaller answer. Huh. So I'm not sure. It must then be the case that the aluminum is really that thin. It is really a micron or less thin. I guess it depends on the grade of aluminum that you buy. It could be heavy-duty aluminum, which is thicker, or it could be the light-duty food service aluminum, which is usually thinner. That's besides the point. Let's go on to the next calculation. Maybe I can erase some of this obstruction. Okay, that's good. So let's move this out of the way. Now an object weighing 1.840 kilograms has this volume, density of water is that. Will the object float? Okay, so really I'm looking for the density in grams per cubic centimeter. So 1 point, I can start with grams. I could start with the data given, or I could start with grams. I've been starting with what I want throughout these videos, so let me do the same over here. So I know that there are 1,000 grams in 1 kilogram. There are 1.840 kilograms here. So, but this is going to occupy the volume of 0.0015 cubic meters. 0015 cubic millimeters, I mean. So the kilograms cancel, and I do have grams, but now I need cubic centimeters on the bottom. And I know that there are 10 millimeters in 1 centimeter. I'm going to cube that to cancel the millimeters. Some of you may be unfamiliar with 10 millimeters per centimeter, but if you are, it's okay. You don't have to use 10 millimeters per 1 centimeter. You can just use 10 millimeters, 1,000 millimeters in 1 meter, and then 1 meter is 100 centimeters. You could do it that way also. I'll actually do it that way here for those of you who are not familiar with 10 millimeters in 1 centimeter. So there are 1,000 millimeters in 1 meter, but I'm trying to cancel out these cubic meters, so this whole thing needs to be cubed. And in 1 meter, there are 100 centimeters. But here I'm trying to cancel out meters, and these meters are cubed, so this whole thing also needs to be cubed. And that's it. That's it. So I've got grams on top and cubic centimeters on the bottom, and I'll just get the answer this way. 1,000 times 1.84 times 1,000 cubed. 1,000 times 1.84 times 1,000 cubed divided by 0.0015 divided by 100 cubed. 0.0015 divided by 100 cubed. That's a big number. That's how many significant figures have I got here? 2 significant figures right there. 0.0015. It's 2 significant figures. So it's going to be 1.2 times 10 to the 1. 2, 3, 4, 5, 6, 7, 8, 9. So the answer is a billion. 1.2 times 10 to the 9th grams per centimeter cubed. Okay, now I think it's obvious that I have done something wrong here. Oh no, I have not. Okay, so I thought I had done something wrong because this density is impossible. A billion grams in a little centimeter cubed, that's like the density of a neutron star or something. But so the reason why I have this ridiculous density is the data is ridiculous. 1.8 kilograms packed into a tiny volume that is so small you can't even see it. This millimeters is 3. Okay, so this is this volume is 1.5 micrometers, cubic micrometers. I'm not sure that you could even see 1.5 cubic micrometers. It may be like, I think you can see it actually, 1.5 cubic micrometers. That might be something like some very tiny fraction of a drop. I think you might be able to barely see it, I'm not sure. So putting this much weight, this much mass into such a tiny volume is not observable on Earth. We might see such a thing in a black hole or a neutron star, but the reason why this answer is ridiculous is because the data was ridiculous. So this is definitely going to sink. It's not. The question is, will the object float? No, this would never float. Not only would this sink into water, it would sink in solid ground. It's that dense. It would sink in solid ground. It would continue into the center of the Earth, and it would stay there. So I was talking about micrometers right here. The answer here was something times 10 to the negative 4th millimeters. So something times 10 to the negative 4th millimeter is more than a micrometer. I think I had the conversion. Not the conversions that I wrote here were correct, but I was trying to do a conversion in my head just to figure out if the answer was reasonable up here. And yeah, this is not going to be less than a micrometer. This is going to be about a micrometer, a little bit more than a micrometer. So that means that answer is reasonable. Something that's about a micrometer. I think it's reasonable to think that a very cheap piece of aluminum foil would be a micrometer thick. I'm not sure that that's reasonable, but I think that's the best we could do with the given data. I think that happened in your lab too. Most of you got a micrometer or some even less than a micrometer, but there was nothing wrong with the calculation. So let's see. Next problem. Square inches. All right. You can see why this is level 2. There's a lot of exponents going around here. So inches. There are 1 inch in 2.54 centimeters. This is 0.00 is just an attempt to get you to think of the 3 significant figures, because there are 3 significant figures there, but there's only 2 significant figures here. The problem should be done with 3 significant figures though, because this is not involved in the calculation. This is a measurement, but it is not involved in the calculation, as you will see. So it's 131 millimeters cubed. So I know that there are in 1 centimeter there are 10 millimeters. So I'm going to have to cube everything because going to be doing this times 131 millimeters. Oh, I'm sorry, I'm going to square everything because this is square millimeters. And I'm going to get square inches. Square millimeters cancel, square centimeters cancel, and I will get square inches. 131 divided by 2.54 divided by 10 squared. So 131 divided by 2.54 squared divided by 10 squared. That's 0.203. 3 significant figures. 0.203 square inches. Box my answer. Forgot to box my answer up here. So the answer here was sinks. It's going to sink in anything on Earth, including Earth. All right, now fly a small airplane, blah, blah, blah. What is your gas mileage in gallons? So I want gallons per mile. Let's see, I have gallons up here, so I'll write that down. 12 gallons in 1 hour. I have to convert hours into miles. Oh, here it is, hours in kilometers. So 1 hour is 260 kilometers, and 1.609 kilometers, this will be given to you if it were an exam, is 1 mile. So in gallons per mile, kilometers cancel, hours cancel, so I have gallons per mile. 12 times 1.609 divided by 260. 12 times 1.609 divided by 260. And that's 0.0743. But there are only 2 significant figures there, so it's 0.074 gallons per mile. Okay. Now the density of water at room temperature, this into kilograms per cubic meter. So I know that there are, in 1 kilogram, there are 1,000 grams, and I have 0.99823, 0.99823 grams in 1 milliliter. Now I want to convert kilograms, to convert milliliters to this thing right here, cubic meters. So I know that in 1 milliliter, there's 1 cubic centimeter, and I know that there are 100 centimeters in 1 meter. But this whole thing is going to be cubed, so I can cancel cubic centimeters with cubic centimeters. The milliliters cancel, the grams cancel, so I end up with kilograms on top and meters cubed on the bottom. That's good. So it's going to be 0.99823 times 100 cubed. 99823 times 100 cubed. Divided by 1,000. Divided by 1,000. That's 998. But there's only one measurement given. It has 5 significant figures, so I'm going to have to use all 5. 998.23 kilograms per cubic meter. That's great. Box my answer. And that's the end of level 2. I'll do a new video for level 3. Thank you, folks.